Hello students, this is Miss Hughes, and today we are looking at conditional probability tree diagrams. Question starts off fairly straightforward, just like a lot of tree diagram questions with counters. So we have a bag with 4 yellow and 3 red counters. Counter is taken at random, color is recorded, and then it is placed back in the bag, and then a second counter is chosen. And we have some probability questions. So I've gone ahead and drawn the tree diagram. If necessary, press pause to check that tree diagram, that you understand how that was done. Except 4 times 3 is 12. Okay. Now let's go ahead and see if we can answer some questions. First one says, find the probability that at least one yellow counter is chosen. So all of these have at least one yellow counter being chosen. And if we add those together, so this probability of this plus this plus this, we actually get 40 out of 49. We could also find that out by doing 1 minus the probability of no yellow counters. So 1 minus 9 over 49 would also give us 40 over 49. That's part A. Part B says find the probability that one of each color is chosen. So that's probability of red-yellow or yellow-red. Both of these combinations give us one of each color. And if we add those two together, we get 24 over 49. Now, for part C and D, we've got the word given and we've got the word if. That suggests conditional probability. And I'm just going to remind you of the formula for conditional probability, which is P of A given B equals P of A intersection B over P of B. So if I look at the probability, this is what I want, right? The probability of this question. I'm going to be very, very careful at wording this sentence here. So probability that a yellow counter is chosen on the second pick. So I want the probability of yellow on second. Given that one of each color is chosen, one of each. And now I'm simply going to apply the formula. So I want, first of all, the probability of yellow on second, and, which is what intersection is, and one of each. And I'm going to divide that by the probability of one of each. Okay, so probability of, well, let's stick to red. Probability of yellow on second and one of each. So I want yellow to be the second, but I want one of each. So that's this root here, which is 12 out of 49. And I'm going to divide that by probability of one of each. Now I actually worked out the probability of one of each back here in B. So that is 24 over 49. Okay. Now you can use a calculator for this if you can't remember how to divide fractions, but if you do so, you've actually got a common denominator, so it's just 12 over 24, which if you like you can simplify to a half. Okay. All right, let's try the next one. I'm just going to change color. And here we go. So part D, if at least one yellow counter is chosen, what is the probability that yellow was chosen on the first pick? So we want probability of yellow on first, given that at least one yellow. One yellow. So, for using the rule, I want probability of yellow on first and at least one yellow. One yellow. Divided by probability of the second part, which is at least one yellow. At least one yellow. Okay, if necessary, press pause. Make sure that you understand how we came to this. All right, probability of yellow on first and at least one yellow. So I want the first one to be yellow, and I want at least one yellow. So that's these two put together. That's 18 out of 49. 18 out of 49 divided by probability of at least one yellow. Now we worked out the probability of at least one yellow back here. It was 40 out of 49. And if I do that division, I get 18 out of 40. And that is the end of the podcast. Thank you.